So here, let's try to solve the modulus of complex numbers. Take note that for a modulus, let's say z sub 1 is a plus bi, the modulus of z sub 1 is actually the distance of the point of this complex number from 0, indicated by this formula. You will have here the square of the sum of the real part, the square of the real part, and the sum of the squares of the real part and the imaginary coefficient of the imaginary part. So this is the formula we're going to use to illustrate here or to solve the modulus of complex numbers here. In this case, for our z sub 1, this is our a, and this would be our b. In short, for z sub 1 here, it's actually a plus bi, or sorry, let's use the actual values. Negative 4 plus 2i. This is actually the square root of the sum of the squares of negative 4 and 2. We don't need I there because we would like to have the value of the modulus here. This is actually the square root. This is 16 plus 4 will get square root of 20. So the result here in a simpler radical expression is 2 square root of 5. This is the modulus of z sub 1. Okay, so replicating the process for our z sub 2, again, this is our a and this would be our b. So the modulus of z sub 2 is the modulus of 2 plus 3i, which is the square root of the 2 squared plus 3 squared. This is actually the square root of 4 plus 9, which gives us a result of square root of 13 in its actual form, because it can no longer be simplified. So these are the results for the first two complex numbers. Now, what if we are tasked to solve for the modulus of the result of a certain operation? I'm inserting that here because there may be some situations wherein we'll be asked to solve for this. Supposedly, this should have this notation, z sub I plus 3 z sub 2. Okay, so first, let's try to solve for negative 2 z sub I, and then you will have to also solve for 3 z sub 2. This is by scalar multiplication, so it's easier to have this situation like this. Negative 2 times your z sub 1 given here and the z sub 2, that's negative 4 plus 2i. This is actually positive 8 minus 4i. And here, you will have 3 times your z sub 2, again, that's a 3. Your z sub 2 is 2 plus 3i. 2 plus 3i. This is, again, 6 plus 9i. And take note, we are to add them. So negative 2 z sub 1 plus 3 z sub 2 would be the sum of both of them. 8 minus 4i plus 6 plus 9i, which gives us, I will do it step by step to remove the grouping symbols first, and then you will have here 8 plus 6 is actually 14, and then you have here plus 5i. This is the sum of these two expressions here. We would want that because that is actually what we are trying to solve here, the modulus of this expression. For here, this is our a and this is our b. So for that, you will have the square root of your a squared, no longer this value, but the value of your actual result here. That's actually 14 squared plus 5 squared. This is now equal to the square root of your 14 squared, which is equal to 196, plus your 5 squared, which is 25. This results to square root of, that's 11, carry 1, that's 2, then you will have here 221. This is now the result for the modulus of the given expression here. So this is by the use of the formula and of course the important properties and fundamental operations for complex numbers. Thank you very much for watching.